Hello everybody. So today we'll discuss about one of the daily quiz questions for engineering mathematics. And if I'm not wrong, this was the quiz which was given to you on during the first week of June. Okay, so let me just write it here. Okay, so this was for week 1 of June 25. Okay, so this is what we are going to discuss, and there were some interesting questions in this, and we'll try to answer them one by one. So let's get started. One second, let me just check one thing. One second. Okay, so let's take the first question. So in this question, they are asking you to find or identify whether this function is homogeneous function. If yes, then what is the degree of that function? Okay, and they have given you this function f as following definition. So this is a basic question on the definition of the homogeneous functions. So we have discussed that in our regular classes quite extensively because we use these homogeneous functions in multiple places. Okay, not only like the pure definition of homogeneous function, it is used in your differential equations and many other places also. Okay, so let's solve it because this is one option correct question. So and they have given you the answer as option D. So let's do that because if you know the definition of homogeneous function, then this is a very easier question to solve. Okay, so if let's say this f of xy is a homogeneous function, okay, in that case then we can write f of lambda x comma lambda y equal to some lambda power n into the original f of x comma y. So this is the definition, and lambda is some real constant, okay, arbitrary real constant. So basically in your function definition, wherever you have x, you're supposed to put lambda x. Wherever you have y, you're supposed to put lambda y, and then solve for the function and try to get the original function and some lambda power n as the multiplier. Okay, if that is possible, then it is homogeneous function. If this equality is not able to, or it is not holding, then it's not a homogeneous function. Okay, so what do we have in this question? We have f of x comma y as square root of x power 6 y power 6 divided by x plus y. Okay, so let me just confirm. Yeah, so this is the definition of your function. And now what you're supposed to do is, you have to evaluate lambda x and lambda y. So wherever you have wherever you have x in the definition, you're supposed to put lambda x, and y in place of y put lambda y. Okay, so therefore this will be lambda x power 6 plus lambda y power 6 divided by lambda x plus lambda y. Okay, and now we are supposed to solve this further. So from the top or the numerator, you can get lambda power 6, square root of that will be lambda cube. Okay, so what you can write is your f lambda x lambda y is nothing but lambda cube, and this terms remain as it is, divided by, you can take lambda common from the denominator also, and then you just have x plus y. So this will give you lambda square into your original function f of x comma y. Okay, because that is the original definition. So therefore f of xy is homogeneous function, and the degree is lambda power. So here it is lambda square, so therefore the degree is 2. Okay, so it's a homogeneous function as well as and its degree is 2 also. Okay, so that is the answer. So if you look at the options, option D is the correct answer. Okay, and that is the same as your answer key as well. Okay, so this is one of the easier questions, but easier only if you know the definition of homogeneous function and how to evaluate that. Now let's go to the next question. So here you have a differential equation, first order linear differential equation, non-homogeneous because RHS is not 0. They have given you one initial condition also, when t is equal to 0, y value is half, and they are asking you to find the correct option for your function y as y of t using Laplace transform. Okay, so this is also very standard problem, and we have discussed this extensively in our regular classes. So here what you are supposed to do is use the properties of Laplace transform, or the derivatives of the Laplace, the Laplace transform of derivatives of various functions. Okay, so in that case, let's go to the next slide. So what do we have? We have y dash. Y dash means first derivative of y with respect to t. So that will be dy by dt also, but let's write it as y dash plus 5y is equal to 2 into e to the power minus 3t. Okay, and y of 0 is half. So this much information is given in the question. So now there is a typical process or procedure to solve these kind of questions. First you have to take Laplace transform on both sides. Okay, so taking Laplace transform. So LT is a short form for Laplace transform on both sides of this ODE, or DE also, differential equation also you can call it, but it's ODE, so let it be. So then this will be Laplace transform of y dash. Laplace is a linear operator, so it will be applied to all the terms individually. And here also you have to take Laplace transform of e to the power minus 3t. Okay, so this is how it will look like. Now Laplace transform of y dash. Okay, so this you should know. It's a standard formula. So Laplace transform of y dash will be nothing but s into capital Y of s. Okay, so just for the sake of simplicity, I'll just write it as capital Y, because otherwise everywhere I have to write it as y of s, and this will be 5 into capital Y. Okay, equal to 2 is as it is. Laplace transform of e to the power minus 3t is nothing but 1 by s minus 3. Okay, no, it is e power minus 8 is 1 by s plus a. Okay, so therefore this will be minus of minus 3, so that will be plus 3. Yeah, this is correct. Okay, so where this capital Y is nothing but function of s, frequency domain variable, is Laplace transform of your y function in the time domain. Okay, notice one thing, that this y is a small y, okay, not a capital Y. Okay, because when you take the derivative Laplace, only the first term has the Laplace transform function capital Y. All other terms in the negative with the negative signs, they are all original function in time domain evaluated at t equal to 0. Okay, so they have given you this information, y of 0 is half, so you are supposed to put it in this equation and then solve it further. Okay, so let's do that. So therefore this s into y minus half, because y of 0 is half, and then you have plus 5y is equal to 2 by s plus 3. Okay, so then you can simplify this. So s plus 5 into capital Y, that will be 2 by s plus 3 plus half. Okay, and then divide both sides by s plus 5. Therefore your y is nothing but 2 into s plus 3 s plus 5 plus 1 by 2 into s plus 5. Okay, so now the next step is to take the inverse Laplace of this equation. But the second part, plus 1 by 2 s plus 5, we can easily do. But this first part, which is on the RHS, which is 2 by s plus 3 into s plus 5, we are supposed to use partial fractions for that. Okay, then only you can take the inverse Laplace and get the desired answer. So there's a standard procedure. Again, we have discussed this ample amount of time in our regular classes. So if you have attended those, you should be able to do this. So since there is no repeated factor in the denominator, you just have a by s plus 3 plus b by s plus 5, no repetitive terms or other things. So then you are supposed to compare the coefficients. Okay, so if you solve this, you'll get a plus b into s plus 3b plus 5a divided by s plus 3 into s plus 5. Okay, and now you are supposed to compare the coefficients, because in the numerator you only have 2. Okay, so therefore this a plus b has to be 0, because otherwise s term will appear, and this 3b plus 5a has to be equal to 2. Okay, and if you solve this, it's easier to do because I can just write b as minus a, so that will give you 2a equal to 2. So therefore you will get a equal to 1 and b equal to minus 1. Okay, and therefore then you can solve this further. Your y is nothing but 1 by a is 1, so that is 1 by s plus 3. B is minus 1, so that will be minus 1 by s plus 5. And you have plus half and that term also, right? 1 by 2 into s plus 5 also there. So that will, simplify further. So this will be minus 1 by 2 into s plus 5. And now you are supposed to take inverse Laplace. Laplace on both sides. Okay. So inverse Laplace of this capital Y will be your small y function in time domain, and inverse Laplace of 1 by s plus 3 minus, keep this half outside, inverse Laplace of 1 by s plus 5. Okay, so s plus 3 we just started with that, right? So this is it is e power minus 3t directly. So therefore your y of t is equal to e power minus 3t minus half e power minus 5t. Okay, this is a standard process. I am not doing anything new here. This is a standard process to solve this type of differential equations using Laplace transform. Okay. So if you go to the options, you'll see, yeah, I think option A is correct, no? Yeah, and that is also the correct answer. Yeah, so it matches with your answer key as well. So these kind of questions are standard and many times asked also. So you should have a good understanding, and you should do enough practice. Okay. Now let's go to the next question. Yeah, this was one of the questions which I found slightly confusing, because see, usually, I mean, this is the complex integration question, and typically when we deal with these things, we use this residue theorem, this Cauchy's theorem, and Cauchy's formula, etc., etc. But in all of those, the pole is basically where your function, the integrand, it goes unbounded basically. So plus minus infinity, whatever it is, but the function value or the integrand value at pole is unbounded. So here, if you look at this, you have a simple pole. Simple pole means order 1 at z equal to 2, and you have a double pole, so that means this pole has order of 2 at z equal to 1. Okay. And z equal to 2 is not a problem, because you are doing the complex contour integration around a circle of unit radius and centered at 0. So it looks something like this. Okay. So if this is 1, this will be 2, this is 1, and let's say this is your 0. So the problem is not with the 2, because 2 is outside of your contour integration. The problem is with the pole at z equal to 1, because it is on contour. Okay, contour of integration. I'm not writing the full thing, but you understand. And I have seen this kind of questions asked in some competitive exams as well. So it is good that it was asked in this quiz as well. Because in regular classes I told you if such thing happens just take the answer as 0. Okay, but in this question if I just check, I think the answer they have given is option C, so this minus 10 pi. Okay, so see the basic confusion comes because the pole which is at z equal to 1, the double pole, it lies on the contour itself. Okay, and if you check any standard book for the the statement of residue theorem or this Cauchy's integration formula, etc., you'll realize that the function has to be analytic on and inside the curve, inside the contour, on closed contour. But the points that you choose or the poles that where you evaluate the residue or derivatives in case of Cauchy's theorems or formula, they have to be inside the contour, not on. Okay, so first of all, this question itself is not completely right, I would say, but let it be because this is practically happening in many exams as well. Fortunately, not in GATE exam so far, but you never know. Okay, so what I have told in the regular classes is, in such cases, we assume that pole at z equal to 1 is there, but the function is analytic everywhere, inside and on the contour. So therefore, the answer should be 0 according to the Cauchy's integral theorem. But since here they have given you non-zero answer, so the question should be complete. Like, I mean, they don't usually do it, but the additional part that they should clarify is that assume that z equal to 1 is having non-zero residue. Okay, because this residue theorem and Cauchy's integral formula, etc., they fail when the pole is at the contour itself. Okay, and how to solve that? There are other techniques like principal value and all those, but those are out of your syllabus, not in the GATE syllabus. So I don't think such question will come in your GATE exam, but in some other exams, if it comes, I would personally put option A as the correct answer. But I think in this question, what they are hinting is basically this z equal to pole also, z equal to 1 pole is also contributing towards the residue. Okay, then only it makes sense to have non-zero answer, because z equal to 2 is anyway outside your integration domain. So your integration in this case, like assuming, okay, because otherwise the answer should be 0. Okay, so assuming non-zero residue at z equal to 1, then only you'll get some non-zero answer, otherwise the answer is 0. But just I think the examiner here is assuming that. Okay, so if that assumption is true, then how do we solve this? Okay, so in this case it's a double pole, right? So this integration of this 3z minus 1 z minus 1 whole square into z minus 2 dz will be nothing but 2 pi I into residue at z equal to 1. Okay, and since it's a repeated pole, you have to differentiate basically, and that's a general formula also. I had given you that formula in our regular classes as well. Okay, so if it is repeated twice, you have to differentiate once. If it is repeated thrice, you have to differentiate 2 times. Okay, so 1 second. See, it is repeated twice here, so there is no need to go into the details. Basically, you have to differentiate once. But I'm just looking for that regular formula. 1 second. Since we are discussing, I'll just write it here. Not strictly required here, but no issues. Okay. So here, this 2 pi I, or maybe we'll evaluate the residue at z equal to 1 directly, and then put it in that this thing. It is nothing but limit z tending to 1. Okay, and then there will be 1 minus 2 minus 1 factorial, because it's a double pole, so that 2 minus 1 comes into the picture, and then you have to differentiate it once with respect to this thing because it's a double pole, so one derivative less than the order of the pole, and then you are supposed to multiply by this term to the integrand, that is 3z minus 1, and the denominator is still same, z minus 2. Okay, so these terms get cancelled, and 2 minus 1 factorial is just 1, so basically you are just taking limit z tending to 1 and derivative of 3z minus 1 divided by z minus 2. Okay, so u by v rule of differentiation, so this will be z minus 2 into 3 minus 3z minus 1 into 1. So the derivative of z minus 2 is 1. Okay, so this residue at z equal to 1 for your function comes out to be I'll write one more step, otherwise I can directly put z equal to 1 in this whole thing, but let's do that. So this is z minus 2 whole square. Okay, and what do you have in the numerator? 3z minus 3z, so that z gets cancelled, then minus 6 plus 1, so you just have minus 5 in the numerator. Okay, and if you put z equal to 1 in this limit, so you have minus 5 as the final answer, and therefore your integration, I'm not writing that again, but you get the idea, the whole integration. We don't evaluate the residue at z equal to 2 because it's clearly outside the contour of integration. Okay, it is nothing but 2 pi I into the residue, so that is minus 5, so that will be minus 10 pi I. Okay, and then it matches the answer given in the answer key, which is option C. But to be honest with you, I would have given option A as the correct answer, but let it be. I mean, this is one of the contentious questions. But yeah, this is like, if you want to match it with your answer key, this is how you should supposed to do. But let it be. I mean, for me, answer A is the correct one. Okay, so let's not go into those. So let's move on. Because for your GATE exam, I don't think they will ask such questions, such confusing questions. Okay, which are technically not correct. Okay, so next question is polar form of complex number 1 plus. So you have 1 plus I as the complex number. Polar form means you are supposed to write this as mod of z into e power I theta. Okay, so from here only you can see mod of z will be 1 square plus 1 square, so that is square root of 2. Okay, and there, then only you can eliminate these options C and D right here itself. So options, one of the options will be correct from A and B, because e power I theta is nothing but, we will go to the next slide. Okay, so it will be square root of 2 e power I theta. Okay, and typically theta is tan inverse of mod of y by x. Okay, and depending on which quadrant it lies, you can do that, because theta is nothing but angle measured from the positive real axis. Okay, and it is always less than pi. Okay, but since this point, which is y is also 1, x is also 1, it is nothing but tan inverse of 1. Okay, no need to do any mod or any difficult calculation, so it is just pi by 4. Okay, since it's a first quadrant point, so this is also pi by 4 is correct. And e power I theta, the formula is cos theta plus I sin theta. Okay, so this is Euler's notation. So here theta is pi by 4, so therefore your complex number in a polar form should look something like cos of pi by 4 plus I into sine of pi by 4. Okay, but we all know that the sine and cosine functions are periodic functions with period of 2 pi. Okay, so typically you can just add 2 n pi to the definition of cos, and still you'll get the same answer because the period is 2 pi. So 2 n pi plus pi by 4, and here n starts from 0, 1, and for that matter you can go negative also, but typically this is the convention. So this should be your answer. Okay, square root of 2 into cos plus I sin some pi by 4 terms. But if you look at this options A and B, none of them have this, if you take pi common, it is 2n plus 1 right here. In this questions, if you take pi common, it will be 2n plus 1 by 4. The reason is because n is starting from 0. So you can just do hit and trial here. So if you put n equal to 1, you can clearly see that the option A is not correct. Option B is correct, because if you put n equal to 1 here itself, the second term is minus I sine pi by 4, which is not true. Okay, so sometimes the options are slightly tedious, so no need to worry. Just do some hit and trial. Just put some values of n, because here they have not mentioned what is the starting point for n. Okay, typically here n will be starting from 1, 2, like that. So more or less the options, like whatever we have deduced here, is the same thing. It's like pi by 4 plus 2 pi, 2n pi or something like that. So pi by 4 is the main thing. Okay, so just by simple elimination technique, you could have answered option B. But the main thing is you should remember this. How do you write a complex number in a polar form? If you do that, you should be able to answer these type of questions. Okay, so let's move on to the next question. Okay, so this is the question. Again, I would argue that this is one of the easier questions. Not because like that, but you can just use options for these kind of questions to solve them quickly. Because in this question, what they are trying to like asking you to find is a cubic polynomial f of x. So basically, you can assume ax cube plus b x square plus cx plus d. Okay, this also you can do. But if you look at the options a, b, c, d, this ax cube. So all multipliers or the coefficients of x cube term are all 1. So instead of having 4 unknowns, what I would do is I'll just write it as 1, and I'll just use 3 unknowns here, a, b, and c. Why? Because like in the options only they have mentioned, right? In all options the coefficient of x cube is 1. So why to assume it as a unknown? You can do it that way also. Nothing is wrong. And another simple information is at x equal to 0, your function value is minus 10. Okay, so assume your f of x as x cube plus bx square plus cx plus d. At x equal to 0, your function value is minus 10. So that will directly give you d as minus 10. Right? So the constant term in the polynomial is minus 10. But that does not help you to narrow down the option, because all the options have minus 10 as the constant term. So what you can do now, there are only 2 unknowns remaining because d we already figured it out. So what you can do at x equal to 1, just check that. What is your function value given in the table? It is minus 12. So if you put x equal to 1, what do you get? 1 plus b plus c minus 10 is minus 12. Okay, so you get b plus c as minus 3, and you just need one more data point, so just take at minus 1. So in that case, function value is minus 18. Okay, so this will give you minus 1 plus b minus c minus 10 as minus 18. Okay, so that will be minus 8 minus 7. Okay, so this b minus c will be minus 7. So now just add these two so that c gets eliminated. So you'll get 2b as minus 10, b as minus 5, and if b is minus 5, c has to be 2, right? C has to be plus 2. Yeah, so b minus 5, c plus 2. So therefore your so this option D is correct, no? Yeah, same. Okay, so this is how you are supposed to solve these type of questions without taking much time. Okay, because otherwise what typically students will do is they will start with 4 unknowns and take 4 points and solve it. But if you just have a look at the options, that the coefficient of x cube term is all 1, so no need to take 4 unknowns, just take 3 unknowns and finish it faster. Okay, so this will be minus 5x square plus 2x minus 10. Okay, so this is how you are supposed to smartly and quickly do this kind of thing. And I think this is the last question. Yeah. Okay. So some interesting questions, but many of them are easily doable if you know the basics. Okay. So with that, we'll stop, and I hope this helps you in clarifying your doubts. Okay. So, we'll meet next time. Okay. Bye.